Hi, my name is Andy Rajuddin. I'm the group leader for my group. So today I will be presenting with Eng Zilin on group project 2, which is on YOLOv5 object detection with custom dataset. So now let's begin. Let's begin on the preliminaries. So what is YOLOv5? YOLO stands for You Only Look Once. It is an AI model designed for real-time object detection. Can also be used for real-time instant segmentation. The architecture of YOLOv5 is based on single stage. It was trained on MS Coco dataset. YOLOv5 also an AI model that is considered to be SOTA, which stands for state-of-the-art AI model for a certain purpose, which in this case would be object detection. And YOLOv5 is also well known to be very scalable. There are multiple sizes which YOLOv5 can comes from, and one can choose depending on whether speed or mean average precision. So balancing between these two will be very important.
Now is how our whole project flow. Our team has decided to use AI model to differentiate between Oreos and Mamee snacks, which means it has two classes. Here is a sample of our annotated dataset. At the top is Mamee, at the bottom is Oreo. Both are with bounding box and transformation applied. And here is the result of the retrain our datasets. We get a 99.9% on MFP. From the RoboFoam metric, it shows that our test set having 88% average precision, and our validation sets having 100% average precision. After that is our transfer learning. We transfer our learned model from RoboFlow into Google Colabs to retrain the YOLOv5 model. After we done our transfer learning from RoboFlow to YOLOv5 and retrain the YOLOv5 model, we get an MMP of 1, which is pretty good. Now let's prove that our model really works.
Okay, so right now we're going to test our AI model performance by presenting an actual object. So as you can see, it is not exactly perfect since it detects our faces as one of those objects. But let's give it a try. So now I will be demonstrating using Oreo. As you can see, it detects the Oreo. However, it was brief. Yeah, let's move it around. There it is. How about to Oreo? There it is. It detects the Oreo. However, briefly. Now let's get to Mamee.
Let's try with Mamee's. Let's see if it detects. Yeah. Let's try with two Mamee at the same time. It detects it as well. Now let's try a little bit different. One Mamee and one Oreo at the same time. Yeah, it successfully detects both at the same time as well.
So that's it for our demonstration. Let's get back to analysis. Hi, now let's talk about discussion and lesson learned from our project. So, discussion on the result. Firstly, we found out that the constructed AI model is a major leap from the previous assignment. It is more specific and more targeted. Secondly, we found out that AI model exhibits vision interpretation delay between input and output, bounding box output. As you can see in the demonstration earlier, there's some kind of delay of tracking by the machine when the object of interest is moving. Thirdly, we see that the bounding box confidence level for Oreo seems to be quite low. It rarely exceeds 0.5 for this case. And fourthly, the object detection is somewhat intermittent. Sometimes it detects the object, sometimes it does not. So it might be a bit unreliable for real-world application for now. So therefore, more iteration will be required. So what are the lessons learned? Firstly, we found out that there's not much can be done to improve in terms of hyperparameters on YOLOv5 retraining side. Because as you can see, the tester board results just now, it seems to perform at optimal performance level. This brings us to the second point, which we found out that dataset preparation proves to be very important in ensuring high mean average precision in YOLOv5 performance. We also hypothesized that it might be useful to train other features as well to prevent misidentification, as in demonstration earlier, it identifies my face as Oreo. Fourthly, we find out that diverse dataset might be useful to ensure more specific identification, which is a bit similar to the third one, but this means that we might include more classes. And lastly, it might be more useful to develop the model on local machine instead of on Google Colab for lower latency. So on the critical self-reflection, we will be evaluating ourselves. So for my part, I believe that after personal reflection, I believe that more intensive fundamental knowledge might be required to understand the model in greater depth. I must admit that there is a lot more reading to do. Secondly, I also found out that it might be quite important to keep up with the latest development in YOLOv5. Since now the version 7 just went out in August 2022, so it might produce some noticeable improvement. Thirdly, I also, after my self-reflection, I found out that delicate care must be taken during dataset preparation, just like the Oreo thing. I believe that it can be better if I had done better care. I have taken better care. Last but not least, I believe that more trial and error must be allocated to produce better data set. Now, to Zalin.
For me, on the self-reflection, a more in-depth examination on the backbone of YOLOv5 is needed to better understand the YOLOv5 architecture. With that understanding, a more optimized dataset can be prepared for this training model. And I have to be more selective on dataset preparation to increase the YOLOv5 accuracy.
Now, we have come to the end. Let's talk about the conclusion of our project. So in this project, we have managed to understand YOLOv5 architecture and its latest development. Then we conducted dataset preparation and annotation by ourselves, which after that, we have integrated the annotated and trained model on RoboFlow with provided YOLOv5 Google Colab Notebook. Fourthly, we have demonstrated the functionality of the retrained AI model. Last but not least, we have determined the possible area of improvement of our retrained AI model. Therefore, the objective of our project has been achieved. So let's talk about the duties and contribution of our group member. So for my part, I have been designated as group leader. Therefore, I dictated the direction of the team. Secondly, I was tasked with annotating the image dataset for Oreo class objects. Thirdly, I've worked on figuring how to cross-link the API between RoboFlow with YOLOv5 codes on Google Colab. This practically means how do we transfer the things from RoboFlow to YOLOv5. And then last but not least, I had conducted research onto certain basics of YOLOv5 architecture and developments. And as for Zalin, he had created the dataset for Oreo and Mamee as well. He had been tasked with annotating the images dataset for Mamee class objects. And he had been responsible in assisting of cross-linking of RoboFlow API with YOLOv5 Google Colab code. Therefore, this marks the end of our presentation. Thank you.